This is solving and graphing absolute value inequalities. So just like with absolute value equations, step one is to isolate. So I'm going to subtract 5 from both sides. And then I'm going to divide both sides by -3. Now, this is an inequality. I just divided both sides by a negative number. So I have to flip the inequality sign. Don't forget that. Anytime, anywhere that there's an inequality sign, you divide or multiply both sides by a negative number, the inequality sign flips. All right, now just like with absolute value equations, here comes the split. The first one is exactly the same. Then I have to decide whether this is going to be an and or an or problem. We'll check out the inequality sign. This is less than. Less than, and. If it was greater, it'd be an or problem. So this is and. For the second inequality, the left side stays the same. I negate the other side, and I also have to flip the inequality sign. Biggest mistake with absolute value inequalities. So let's solve each one. Add 4 to both sides. X is less than 11. And add 4 to both sides. X is greater than -3. So this is going to be an and problem where they face each other. So I'm going to get a line segment between -3 and 11. If you're not sure about that, make a rough draft graph and find the intersection because it's and. So it's between -3 and 11. So in interval notation, that'd be not including -3, open circle parenthesis, to 11, not including it. Again, an open circle, so I use parenthesis again. So this next problem I want to solve and graph, step one is to isolate. Well, great, it's already done for me. Less work, sweet. So, time for the split. First one is exactly the same. Again, look at this sign, greater. So it's an or problem. For the second inequality, I'm going to negate the other side and flip the inequality sign. Solve this, I get, by subtracting 3 from both sides, I get x is greater than 7 or x is less than -13. Now, this is the case where they face opposite directions in or, so that's my final graph. If you're not sure about that, then make a rough draft graph. But I am sure, so I'm ready to make the graph. So it's going to be this guy. In interval notation, it'd be from -infinity to -13, not including it. It hops from 7 until infinity. All right, let's take a look at 2 special cases. So, over here, I've isolated the absolute value. It's greater than a negative number. Well, when is distance bigger than a negative number? It's always bigger than a negative number. So the answer to this is all real numbers. When I graph it, I get the entire number line. Interval notation, -infinity to infinity. Now, if I actually split it and solve it, you'd end up with an or problem where the graphs face each other. So you'd end up with all real numbers anyway. But it's easier to recognize it before you split. You're saving time. And you're minimizing your chances for error. Over here, I have the absolute value is less than a negative number. Well, this is just like when it's equal to a negative number. This is saying, when is distance less than a negative number? Well, it can't equal a negative number, yet alone be less than a negative number, so this one is no solution. But again, if I actually split and solve, this is an and problem where they face opposite directions. There's no intersection, so it'd be no solution. So even if you missed it, if you solved it all the way through, you'd still get the correct answer. And that's a quick review of absolute value inequalities.